Hi, welcome to this tutorial about K-bracing and how its role plays into the structure of the trusses and the importance of why we do it and how to do all of the components. This is a Chesney house plan that has had the trusses flown and the appropriate temporary bracing installed. At this point, it is ready for sheeting and subfascia and all the others, but we've left that off so that we can see into the structure of the house plan and the trusses. Here, everything highlighted in blue is the K-bracing structure that we'll be making this video about. We'll take the other trusses off here so we can see it in entirety, but remember that it is integrated into the trusses. So here is the gable end of the truss, which is susceptible to winds from the outside and has some deflection on the middle of the truss unless we put K-bracing on that will give it that structure. Here is kind of a general overview of what it looks like. But let's take a look at the truss plans and what the manufacturer has done and given us for instructions. So as you get the truss package, all of the trusses have their own page that describe each individual element of the trusses. And at the end of the package, we have this page that we're already on. That talks about it. See here, this is a gable end, and if we look over here for that same gable, that is a gable end. Come to think of it, I have drawn the this gable end incorrectly. You can see that the internal webbing is got some diagonals. Every so often you'll have a gable end that has diagonals in it, but for the most part, the gable ends will all be vertical. All the internal webbing of the truss will be vertical. So over here on the house plans, let's go back over to this one. Here's that gable. It has all of the vertical trussing, webbing, sorry, and the information on how to install the K-bracing. K-bracing on the side view is here, and then from a straight-on view is here. In fact, I could probably take and match that there. See that how we have this diagonal coming across here and that diagonal coming across there. With that said, let's just read this page and kind of get some information of what the K-bracing is. As a general overview of where it is, here's the height of the gable, and that height is going to tell you which piece of information to use. For gables that are 4.5 feet tall, you don't need K-bracing. It is strong enough to withstand winds. This particular plan will be able to, if done correctly, withstand up to 120 miles per hour and have the structure associated. So here we are. Heights of the gable greater than 4.5 up to 7.5 in length will be installed like this. You'll put a 2x6 stiff back. Stiff back is this part of the truss that has, or this part of the K-bracing that has been nailed to the gable, and then this 2x6 nailed to that 2x6. That would be what's called the stiff back. That'll be installed at the mid height of the gable, so measure from top to bottom, snap a line at the mid height of the gable, and if we look down here, we will nail it with framing nails every four nails every vertical member of the truss. So first off, nail that 2x6 to the gable. Now, if you have a gable that is longer than a 16-foot long 2x6, just put the splice on the middle of one of the vertical members. And if you do that, you'll also have this piece here have a splice as well. Try and put the other splice on the other side of the truss so that both splices are on the same. That's just how I would do it. So we're going to nail that with 4 nails every vertical member, and then we're going to nail this 2x6 to the bottom of that 2x6. And if you look here, it'll show you that we're going to be nailing it every 6 inches along the length of that. So that is installed, 2x6 stiff back, and then the difference between the 4.5 to 7.5 instructions and the 7.5 to 12 instructions is how often we put one of these. On my drawing here, I only have one, but in reality, it is telling us in this paragraph here that for the 4.5 to 7.5 gable, you're going to put one of those every 6 feet to the side. So we'll put one in the center, and then every 6 feet. So 6 feet to the right. Let's see, every 2 feet. So 2, 4, 6. You'll put one here. Every 6 feet would be from here to here, and then you'd put another one of these on the other side. So in this example, if it fell into that category, it would get one in the middle and then one over here and one over there, so 3 total. In this detail, it says instead of 6 feet from 7.5 to 12 foot in height, we're going to go every 4 feet, and that will just be every other vertical truss or vertical webbing of the truss. So it'll get a lot more, but it'll be a bigger gable in the first place. That is pretty much the description of the K-bracing. If we were to look at just this part of the K-bracing that is described here, it shows that we were going to want it on a 45-degree angle, and you can see that as it gets toe-nailed into here, and this is just a 2x4, as it gets toe-nailed into here and then goes up to the roof deck, you're going to want to nail it to something. So that's where this 2x4 blocking comes into play. That 2x4 will be nailed to the top of the truss wherever it hits the roof deck, and then nailed, the K-bracing nailed to that piece. Now, it's drawn here in this drawing, and in my other drawing you can tell, in fact you can't tell here, let's go to this one. It is drawn closer to the truss. Now, you can vary that 45-degree angle just a little bit, but if you needed to, you could, for example, if this was sitting a little bit closer to that truss and needed to go through this section of the truss, you could get it so that it goes just a little past. But for the most part, you're just going to want it to be at that 45-degree angle so that it gives that structure to the trusses. And that's K-bracing. Thank you for watching, and we'll be looking into, in the next video, we'll be looking into some of the other internal bracing specifications that the truss manufacturer is wanting for some more structure.